So good morning to you all. My name is Filipe Martinho, and I'm a researcher at the University of Coimbra in Portugal. And so I'm going to try to give you some insights on how there has been these long-term changes in seabass populations. So you've seen this throughout the morning, so I'm not going to go into detail. So basically, all of the life cycle of sea bass, you know it. They live at sea, they reproduce, juveniles go into estuaries, and then they come up back at sea. So they usually call these species like marine estuary independent species. And actually, the bass is one of the most abundant species in Europe. So that's why we've been also working with it over the last years. And what do we know about sea bass recruitment? And so we know that the timing of at which key life cycle events take place is actually a crucial factor for the population dynamics of sea bass. We also know that stuff like changes in oceanic and atmospheric conditions due to global climate change can actually impact on fish early life history. So we are tackling that. And one of the best methods that we actually do have to tackle these questions is to use long-term monitoring programs so that we can better understand the relationship of how climate actually changes these parameters in the fish life history over time. And usually we tackle questions related to water temperature. That's usually the main thing, but we can also look into things like rainfall, river flow, upwelling, or what we call some large-scale climate patterns like the North Atlantic Oscillation, the Atlantic multi-decade oscillation, the El Nino that we all know. So that's basically what we did. So here we are in Colchester. This is the Mondego estuary in Portugal, about 1,500 kilometers away. So back in 2003, we started a monitoring program in the estuary. So, and we have been doing it for the last 21 years. Nothing has changed much. So what we do, so this is the Mondego estuary, and we chose these 5 sites that cover the whole estuarine gradient of salinity. And so we sample them, well, basically whenever we can. So the first thing that I'd like to share with you is that we wanted to analyze the variability in the recruitment. So these 0 groups moving into the estuary throughout time. So between 2003 and 2019, and to try to understand if there's anything changing in climate that actually was explaining this. And so we use, again, monthly 0 group densities and also some environmental data that we obtain. So as you can see, so these are the variable variations in the abundance of sea bass through time, and you can see this seasonal pattern, and that's of course given by the arrival of juveniles every year. And since 2010, there has been a tendency actually for the abundances to increase. And also going on through some fancy statistical analysis, not going to show into detail, but then the major trend in the data set that we have this model that shows this trend, and this model is best explained by the densities of the juveniles, and also by the water temperature inside the estuary, and also by this what we call this AMO index. So it is Atlantic multi-decadal index. That's also having some importance here. So you can just, never mind the units, just look at these trends. So we have these two clear trends. So from 2003 to 2010, there was a decreasing tendency. So in the abundance of the juveniles, and then after that we have this sharp increase. So we have this period, and we wanted to know what happened there. So we look into our 2 main environmental parameters. So going to the first, so the first is the AMO index, and you can see in 2010 there was this sharp move from a very negative index to a very positive index. And what does this mean? This means that there was actually a regime shift in the Atlantic, and then from there on temperature started to increase. Also, looking at the temperature inside the estuary, you can see basically from 2010 onwards, the winter temperatures in the estuary also started to increase. So what can I say? So water temperature actually seems like the main driver here to influence the abundance of bass juveniles. And how does it work? So mainly it can promote growth. it can promote better feeding conditions, and also to promote some better overwintering activities. So their chances to survive are going to be higher. So next case study. So we then also wanted to try to understand what was going on the juveniles, if they were hatching, later or earlier, or what was going on. So we did this from data from 2011 to 2017. Again, then trying to get some environmental data to try to explain what was going on. So we also had this otolith-based estimation of hatch dates from 2011 to 17, and also some environmental data. And I'm not going to show you because Joe did a good job explaining how do we get data from the otoliths, but just bear in mind that for the study, we had data from 250 juvenile seabass and for over 14,000 otolith daily increments. So what you can see here actually is the variation of the hatching dates through time. As you can see that, so here in the Portuguese coast, you'll have the mean hatch dates around here, day 60, day 70, so late February, early March. Two exceptions that can be noticed. So in 2012, they hatched really early in the year, so late January and February. And in 2016, the mean hatch dates were actually much later. And also, okay, I'm going fast. So the shortest hatching period actually occurred in 2015, just 41 days, so really concentrated in time. And in 2016, as you can see, the period was really long. So long story short, again, modeling techniques showed us that there was this positive relationship with water temperature, which means that because the temperature is getting warmer, they're actually being born later. And that's a bit contradicts a bit what might happen here up north. So the take-home message I'd like to give you is that water temperature is actually the main driver for this juvenile bass abundance in the Portuguese coast. Again, by favoring the juvenile abundance. Again, so temperatures are increasing because bass is actually benefiting from this. Of course, until they reach a tipping point. Okay, if we go harder than that, then there's going to be problems. Also, larval hatching again matches really well what Kieran actually showed you in the beginning. Again, southern populations might actually show different relationship with temperature than the populations further north. And then there's also the question of sex reversal and sex ratio. Again, because higher temperatures will probably lead to more males in the population, and we need to know what's the effect it's going to have. And as a final message, I would like to say that these long-term programs are one of our best ways for understanding bass in this changing world. And it's really hard to get funded, but then we should foster those. And with that, I'd like to thank all of the team and thank you for listening.